Hello everyone, welcome to this session. So in this session, we will talk about categorical data. First, what is categorical data? So for some data, they can be part of a specified set of categories. So for example, you have a second-hand book. It can be new, like new, or used, one of these categories. So if you have a car, it can be 3 wheels or 4 wheels, right? So the categorical data cannot have multiple assignments. So for example, an animal have different categories. It can be both a tiger and a sheep. It can be either a tiger or a sheep or none of them, right? So one categorical data can't have multiple assignments. So categorical data are very common in machine learning because most of the data comes from machine learning, comes from survey. Let's say from questionnaires, for example. So those are some of the data are categorical. A special kind, we call it Boolean data. It means it only have true or false. And this is a special kind of categorical data. So now we have categorical data. So how to handle them in MATLAB? So we can create a categorical array using the categorical function. So categorical parentheses A. So what is A? A is an array or is a matrix. So we can say it's an object have a distinct categories. So these categories can be numbers or can be strings. So let's show an example. So here I put a matrix of colors. So these colors are strings, right? So from red, blue, green. So these are the colors. So now I use this function, categorical, to put the matrix colors in and the generated colors. So this one is a categorical array. Another example, I can create an array of shapes. So I use square, circle, triangle. I put this matrix in and generate a categorical array of shapes. So the question is that, why do you do that? So how can we use these colors and shapes? So on its own, it's not very useful. But later you will see some functions that it only accepts categorical arrays. That's why we need to do this. But before that, let's learn more about categorical arrays. So categorical arrays can be combined with non-categorical arrays, for example, into a table. So let's see this example. I generated a variable called width. So width is just a matrix. It's not a categorical array, but in the table, I can use a table function to collect the colors, the shapes that we have used before with the weights, make them together to be the objects. So objects is a table, is a 6x3 table, right? This is not categorical. These two are categorical. Okay, so when we have categorical data, how do we handle them in machine learning? So often there is a way to represent them. We call it a one-hot encoding. Consider the case where an item can belong to 3 categories, right? 3 categories, A, B, or C. And one-hot encoding, we can represent the probabilities of an item belong to each of the possible discrete categories. So we can see the PA, P means probability. The probability the item belong to category A, the probability of the item belong to category B, as well as C. So how to do a one-hot encoding? We can do the following steps. Step 1, for data with n distinct categories, we first know, okay, n distinct categories will create an array of n elements. So each category corresponds to one index. Then, for the index corresponding to the item's index, we place 1 here. For all the others, we place 0. So maybe this is too abstract, right? But when we see an example, it will be easy to understand it. So we can see this one. Now I have an object with 3 categories, red, blue, green. Okay, let's do the first step. We create an array of 3 values. The first item refers to red, second refers to blue, third refers to green. Then we see each object. So if it's red, then we place 1 in the red place. And the others are 0. So vice versa for the others. So now let's see for the 3 items, if it's red, blue, green, then we will generate this one. So we can see if it's red, the color is red, we put 1 in P red, 0 and in the P blue and P green. Blue, we put 1 in P blue, 0 in the P red and P green. The green, we put 1 in P green. All the others are 0. So this, the result of this, we can see 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is a one-hot encoded of these 3 items or 3 objects. Right. So how to do one-hot encoding in MATLAB? Here I first write a custom function. So we call it one-hot encode, category underscore data. Now this is for your homework. So you can read this program and see how does it works, right? So some hints we can see. First, we use a lens to get the cat data. This is the objects, right? Then we know the number of items to encode. Through these 2 lines, the unique function and this lens function, we know the number of categories. The unique function we haven't taught you before, right? If you also appear in the counting sessions, and I suggest you to look at the MATLAB help file to understand what this function will do. So now after we know the number of categories, we create a 0 matrix of the number of items by number of categories. It's an all 0 matrix. Then when we find an item belongs to its category, we place a 1 there, all the others remains 0. So this is a custom function, and you can study it and see how does it works and try it. So MATLAB has its own function, built-in function, we call it one-hot encode. So here is a hyperlink, so you can see this function, this help file is here. So this data is the same as this category data. So this 2 is another argument. So this is telling you the output one-hot data, what is the dimension of that. So it at least needs to be larger than the dimension of the category data of this one. So for example, if this is one category data, one-dimensional categorical data, then this one should at least be 2. So let's see an example. So we can see we generate the shapes matrix. Then from here, we change it to a categorical arrays. And one-hot encode, this function only accepts categorical arrays. So categorical arrays is here. You can't put shapes just directly here. You need to first change it to a categorical array. Shapes cat, then we put it here. 2 means dimensions. So for this one-dimensional categorical data, what you generate? If you generate this. So the number of items, number of categories, we can see there are 4 categories. These are the item 1, 2, 3, 4, 6. So this is a 6 rows, 4 columns matrix showing the one-hot encoding of them. And you can see if you compare this with what has previously taught, you will find that these are the correct one-hot encoding of them. So when the data is more than 2-dimensional categorical array, so what we will do for higher dimensional data, one-hot encoding. So let's see. We first create a 2-dimensional categorical array, so 4 rows and 6 columns. So we can see with red, blue, green, I use the regmat function that we have talked about 2 weeks ago, right? To repeat them, and I use the new matrices to form a matrix. Then I put categorical out to make this becomes a categorical array. We call the cat underline array. So this is a cat array we generated 4 by 6. So red, the first two rows, blue is here, green is here, and blue also here, right? So this is a cat array that we want to carry out one-hot encoding. So how can we carry out one-hot encoding? we still use a function one hot encode. So the array, comma 3. So why we use 3? As I've said, the data have 2 dimensions. And now, so this one should at least be larger than that. We use a 3. Then the generated one hot encoded data has what kinds of dimensions? Remember, this is 4 by 6. If you have 4 by 6 by 3, so 3 is the layers. So we can see the result is here. 4 by 6 by 3, single array, right? So we can see the first layer, the second layer, the third layer. So this layer refers to the blue. This layer refers to the green. This layer refers to the red. So this is one hot encoding of a higher dimensional data. So why we need one hot encoding? You may ask this question. Because it can represent the probability of an item belongs to a category. So for probability, it's not necessarily that each object, the probability, the entries is 1, but the sum of all the probabilities must be 100%, right? So for example, for a given picture of animal, a machine learning model wants to predict the species of this animal. So it can provide the probabilities of this animal belongs to each category. So sometimes we may have this, all the 4 categories, 0.25. So this means equal probability of these 4 categories. In the previously, we have seen is 1, 0, 0, 0, 1, 0. That is why, because we know the true species of the animal before, right? So we can put it like that. But a machine learning model will predict, different probabilities of each category. And if we know the true species, we can compare them with the predicted probabilities, right? Then we can know that the machine learning model is good or not. Okay, so that's all for this session. Thank you very much. Bye-bye.